Welcome to the Hyperledger Member Summit 2020. This presentation is going to cover a blockchain-based license management solution. This solution is built upon the Hyperledger Fabric blockchain solution. This was a co-developed project by Lenovo and Chainyard. Your presenters for today are Rod, a distinguished engineer and chief architect for Lenovo's cloud-based solutions, and Mohan, the chief technology officer of Chainyard. So today we're going to cover a bit about the problems that we had to overcome to build a licensing solution based on blockchain. So we'll start with the business scope and pain points, why we chose blockchain as a solution to actually implement this on. And then we'll go through some of the example UI and workflows on how customers can manage and look at their licenses. We'll do a deeper dive into the technical architecture, and we'll cover the platform selection and rationale. So a little bit about Lenovo. Lenovo is a $50 billion a year company. We're the #1 PC manufacturer on the planet. We average about 1 billion devices shipped a year. We have 2,000 suppliers. We cover 180 markets and 34 facilities. This presents a unique set of problems that allow us to sell at scale, but we need to manage and license those solutions at scale as well. So this presented several problems for us. One is the biggest disparate licensing types. We preload software on systems, we do direct sales, we resell third-party software. Because of all this, we need to have an integrated solution that allows us to manage all of these different requirements and unique customer engagements. You know, every customer, particularly large enterprises, have unique requirements or solution spaces that they want us to cover. This implies a unique license in some case for those customers. And in other cases, we have hundreds of millions of end user customers, consumers that want to have their experience, and we need to be able to have very fast, very simple transactions for them. We also need to be able to stay engaged with our customers. Lenovo, because of the nature of our business, we sell direct to customers, we sell through third-party resellers, and we sell through what's called value-added resellers and other organizations. So we have multiple degrees of separation in some cases between Lenovo and our customers. We want to be able to provide a connection through all of those and manage it. We need to have a high-speed and low-cost-based solution. With over 1 billion devices shipped in a year, that's over 2,000 devices activating every minute. That means we have to have a high transaction speed. We have to have the capability of managing this number of licenses. A typical device may ship with 10 or 20 pieces of software. If we put licenses on each of them, we have over 1 billion licenses coming in, and then you multiply that times the number of devices, you get a very large scale. So because of that, we need very low cost per license issue. We need to provide full cycle life management of the solution so that we can manage licenses from creation to sale to resale to transfer to corporations being able to manage the licenses as they do their day-to-day business. This led to several categories of efficiencies that we needed to overcome. We need to protect the licenses and the data that's associated with them. This means we have to adhere to privacy requirements. We have to store the licenses securely. We need to have encryption both in flight and at rest. We need to be able to do this all at scale, as you saw. Some of the key pain points that we wanted to overcome were be able to build trust and transparency with our licensing. So as customers are using the licenses, we wanted them to be able to have viewing the ability to trace their licenses through their usage. We wanted to be able to prove that the license was genuine and not a fake. We wanted to maintain our customer connection. As I said before, there's degrees of separation between Lenovo and our customers. Because of this, we need to have the flexibility and efficiency to manage disparate license types and the rules We want to be able to allow customers to have visibility on, are they using the licenses most efficiently? Do they have the right number of licenses? Do they need to have more? Could they get by with fewer? We need to adhere to all the privacy and confidentiality requirements, both Lenovo internal policies, and we have to honor corporate and corporation or countries' rules and regulations. So European rules and regulations are different than US regulations, are different than Asia and China and so on. So we need to have flexibility in honoring the different rules and regulations in each geography that we're doing business. And finally, we needed to manage and supply capabilities to do audit and compliance reporting. So this allows us to present the interface that allows the user to get real-time usage reporting. They can generate reports that generate lifetime usage cycles, their utilization. That allows them to be able to prove that they've been in compliance throughout the entire lifetime of the license. And we need to scale from end consumers that may have one or two licenses to large corporations that are buying hundreds of thousands or millions of licenses. To do that, we needed to have a licensing tool that supported varying license types. So we needed to support floating licenses, which are basically a license where you can oversubscribe. So I could buy 100 floating licenses and I may have 200 employees at my company. So at any point in time, 100 of those employees could be using the license, but at any given point in time, it's probably not the same 100 employees using that license. So that license can move from user to user based on what they're doing. We had to be able to control usage and time-based limits. So for leasing of software or hardware, you pay for a term, 30, 60, 90 days. The license is active during that time. If you don't renew, the license becomes inactive at the end of that lease, and the device or software stops operating. We have to support renewal, managing expiration and cancellation of that. And again, we wanted to have visibility of the license and the transactions from the OEM or the point of sale all the way through to the end user, so that we can maintain a valid and exceptional customer experience relationship throughout that. Why blockchain? So blockchain provides several key capabilities for us. We need to have transparency, as you saw, to be able to generate the reports and be able to prove that the transactions are there to support auditing and compliance. We needed to have traceability, so we needed to be able to understand the life cycle of that license from the point of its creation through the transfer from various resellers, and maybe through a company that's going to sublease sections of the license. So they may buy 100 licenses and they may sell 10 to a smaller company and 20 to another company, and so on. So we need to be able to track that sort of usage model throughout the different customer engagements and experiences that we had. Blockchain was very good because it satisfies all these requirements and provides a transaction-based mechanism that's secure and encrypted. From a user standpoint, when I create the licenses, we want to be able to not only create the licenses and the entitlements, but I need to bind to them uniquely based, in some cases, based on the relationship I have with that customer. So as a license creator, I want to be able to have visibility to all of the different license types I have, where they're currently active, inactive, are they available to be sold, activities like that. So I can go and create custom entitlements to build, effectively a license that's customized or tailored to a particular customer's requirements. As a customer, I want to be able to view the licenses that I've currently bought, and again, be able to see which ones are active and inactive. I may want to be able to transfer or assign them to other users. This allows me to have a good user experience because I've got a UI that gives me visibility to all of that data. Today, that's actually pretty hard to do. There are license managing tools that allow you to get some visibility on this, but they don't allow you to be able to manipulate the transactions and be able to transfer and adjust the licenses conveniently in one spot. From an architecture standpoint, the licenses need to be flexible, so we designed the licenses around the legal definition of license, which is more of a container for entitlements. And then the entitlements grant or deny specific permissions or restrictions or liberties within the license. Because of the way we built this, we wanted to support multiple different license types. We wanted to be able to support different binding criteria. Are we binding to the user, the device, specific features? Are they multi or single user licenses? Are they time expiration? Are they usage based? We also needed, as you see in the example on the left, be able to mix and match different entitlements. So I may have a base set of software that is offered, and then I have an enhanced or upgraded feature. So I may have a license that starts off with one set of entitlements, and then the customer decides they want to upgrade, so we add an additional entitlement that provides the pro features. Same with hardware. I may want to license a package from Lenovo, and that would include hardware and software. So the license would be for a particular device that could be a lease, and it would include hardware and software entitlements. This allows us to custom tailor the licenses based on the need of the particular situation or agreement we have with the customers. Deeper architecture standpoint, our entire solution was built upon Lenovo's user device and services platform. This is our microservices-based platform that provides the ability to have base level functionality. So we have, database solutions and identity management, role-based access controls. This allows us the flexibility to tie in, so a customer can log in with their Lenovo created ID in the case of individual users, and they can view and manage their license types. But in the case of larger enterprises, they can tie in with their Active Directory or Kerberos-based identity management and still be able to view their resources and activities. We needed to create a license asset manager that allowed us to aggregate all of the different licenses together, as well as a software asset manager that allowed us to be able to have more control of the individual components of the software, like for upgrading specific functions or features. In the case of Lenovo, since we manufacture the devices, we have additional device inventory data that we provide in our UDS platform that couples tightly with the license management solution. So if we tie that with the on-device license management agent, we can combine that for hardware or software enablement. And since it's bound on the device, it gives us the capability of doing enforcement locally, either hardware-based in the case of hardware licensing, or purely software-based in the case of a software license activation or deactivation. This also allowed us to be able to manage a wide variety of devices. Since Lenovo manufactures from cell phones, tablets, PCs, all the way up to high-end, high-performance computing servers, we have a very broad range of compute capabilities. So we wanted the ability to provide control and permission-based entitlements, but we didn't necessarily want to be able to have to run the blockchain on a cell phone, for example. So by having a license-based agent, we're allowed to be able to tie and couple directly to the blockchain and extend its enforcement and transaction management down to the device without having to do proof of work or things like that on a cell phone-based device. I'm now going to transition over to my friend Mohan, who's going to talk about the blockchain pieces and how that tied in to provide the enforcement. So Mohan, over to you.
Thank you, Rod. Good afternoon, good morning, everyone. I just want to talk briefly about this architecture from a blockchain standpoint. So as you can see on the right side, we have the blockchain network. It's a network of permission nodes. And in our network, we do envision the participation of customers, Lenovo, and software vendors or hardware vendors as part of the ecosystem. Some of the members could operate nodes, and other members could just be users of the system, and they would use other members as trust anchors. So that's kind of like the architecture of the blockchain itself. Now, within the blockchain, we do have smart contracts, and the role of these smart contracts is essentially to act as a system of record for licenses and entitlements that have been created, assigned, and processed. Now, the important thing to note about it is that both these contracts try to mimic the real world legal contracts in terms of execution of the business rules. The blockchain itself serves as not only as a system of record, but it also provides audit capabilities and verification for compliance with prevailing policies and procedures. In order to access this blockchain, we have to have a blockchain API layer. And so this blockchain API layer is the only way by which one can communicate with the blockchain. And that API layer interfaces with a security agent such as a certificate authority. It also has role-based access as to which functions can be accessed by which roles in the network. So kind of that is the portion of the blockchain network. And the way the network itself has been engineered is to take advantages of Kubernetes and Docker for scalability and ease of deployment across multiple zones or multiple regions or even multiple clouds. So we extensively use Kubernetes and Docker as part of the engineering of the blockchain network and the API layers. Now, there is an advantage. This allows us also to separate out concerns. So for example, if this network is subscription based where members have to pay for their own nodes, then we can easily isolate out clusters into independent Kubernetes clusters, and that way it simplifies our billing. So there's a lot of thought into how we want to engineer this network when we actually get into production, but that's really the blockchain portion of this solution. Now, in the next slide, what we will see is what kind of criteria has to be applied in order to make the right decision on the blockchain platform. But of course, before that, I do want to talk a few things. License management is a very important domain that we have seen come several times in Chainyard's implementation. So we have seen in different organizations, they bring up the topic because it has got a lot of implications. One is, how do you manage licenses effectively? How can you control the cost of licensing? How can you prevent penalties from misuse of licenses? So there's a lot of trust and transparency required in license management. So we have done at least 3 different projects other than this current one. And we've seen that there are various ways by which you can tackle this problem. The initial days we used keys before tokens came into play, and keys were tagged to license entitlements as well as software that could track the usage of that particular license. Later on, we worked on another project where enterprises or even federal government can procure licenses in bulk, and then they can distribute these licenses to different agencies or to different departments within their company or different business units. So how does one track the usage of licenses? How can one recover licenses that are not being used, and how can they optimally use these? So we used tokens in this tokens as a model for designing this on a blockchain network, and that seemed to definitely give us some advantages for certain types of licensing models. Now, lastly, in this particular license management, you do see the play of IoT and hardware as part of the overall licensing solution. So it's not just restricted to software. So decentralized identity and credentials management based on W3C standards can definitely play a key role. So as we evolve the solution, we do want to apply these kinds of thoughts into the solution to make it more robust and to make it more innovative from today's perspective. With the next slide, let us see what are some of the things that one has to consider before they choose a blockchain platform. So there is no bad blockchain platform or good blockchain platform, but every platform has got certain characteristics that solve certain problems. In our case, we are dealing with business problems and business networks. So the blockchain has to support business networks and business collaboration between different partners, like in our case, customers, software vendors, Lenovo, in an ecosystem. The second is we do not want the blockchain to be powered by cryptocurrency as they do it in public blockchains. Powering by cryptocurrency with the fluctuations and the volatility of the crypto itself can be a disincentive to participate in the network. There are other criteria, like we do not want any limitation on the code size or even the payload that is provided in the transactions. We want high performance and low latency. We want to see as soon as a transaction is initiated, it is processed and recorded on the blockchain. And unlike public blockchains where it can take a few cycles to a few hours, we want to see instant finality. We also want to have commonly used programming languages. Resources should be easily available to build smart contracts, such as C programmers or Golang or JavaScript. We also want to have the ability to support private and public transactions because we are dealing with businesses. In a business scenario, a business entity can have a private relationship with another entity and public relationship with all entities. For example, a software price and licensing information could be personal and private between the software vendor and Lenovo, but the usage of it is public between all the three parties. So portions of that should be supported on a public ledger versus private ledger. And last but not the least, we do want the technology to be a long-term technology supported by either a major vendor or at least by a major foundation, and it should last. So with these criteria, what we felt was that Hyperledger Fabric would definitely meet the requirements for our project. As you see in the next slide, so Hyperledger Fabric is hardened for enterprises. It's one of the first permission blockchains, away from the traditional crypto-based blockchains like Bitcoin and Ethereum. Hyperledger Fabric provides certain capabilities like it's non-crypto, it's permission. That means members of this network have to be permissioned into the network before they can start transacting. There are certain other capabilities that this particular platform provides. For example, it has support for channels. Channels can help isolate out different collaborations between the various business partners into their own separate blockchains. For example, licensing models could be independent blockchains and they converge on a common ledger for other purposes. It also supports private data. So things like a private relationship between two parties where there is price involved or any other confidential contractual information can be in the private ledger between those two, shared between those two parties or three parties. And then the public data can be in the public ledger. And transient data support is very essential. In fact, if the data on the blockchain is being encrypted and stored, and let us say the decryption key has to be passed in, we do not want the decryption key to be visible on the ledger. So the support for transient data is one of the good features that Hyperledger Fabric provides. Now, other things, we want finality, which is immediate. So the consensus algorithm plays a critical role. So rather than use proof of work, we have Raft, which is a leader-based protocol, and also an ordering service that allows transactions to be ordered and recorded on the blockchain in the form of blocks with near real-time visibility. So that is very key in our application, especially when we are dealing with thousands, if not millions of licenses and transactions in a day. And we are also dealing with thousands to millions of devices and products that Lenovo transacts. On the other side, it is very hardened for business, meaning like it provides natively support for consortiums. It also provides native support for security in the sense it provides a certificate authority that issues keys and certificates and member services that sign transactions and verify transactions. Out of the box, you also get certain security aspects like identity mixer. You also get it's also out of incubation, meaning like the product has been mature for quite some time. It entered 1.0 version back in 2017, and it has gone through several cycles of maturity. And last but not the least, this product is backed by IBM and supported by the Linux Foundation. So all this makes it a very attractive platform for permissioned enterprise blockchain problems. In the next slide, you'll see what are the things that it takes to take this solution like license management, which we see, all the way to production. There is several things along the way that one has to care about before a product or before a solution can become production ready. And Chainyard's experience that we are bringing to Lenovo has taught us the following things. One is, how do you network engineer the solution? It's very important when you engineer the solution to have the right firewalls, the whitelisting, the intrusion detection, the security event management tools, managing malware, as well as scanning for viruses as the data comes into the system. Network engineering plays a very critical role, and how do you architect the network in terms of nodes and clusters is also very important. The second is business continuity and high availability. Businesses have to work forever. Public blockchains are always alive 24/7. We want to have the same capability in permission blockchains. So we have to look at how do we distribute our nodes and our solution across multiple regions, multiple zones, and how do we implement backup and restore just in case there is a failure. We want data management and data security, like compliance with privacy laws such as GDPR or the California Privacy Act. We want compliance with how do we store the data while it is at rest and while is it in motion. We want to make sure that the data sharing is based on appropriate roles and permissions. And finally, there is data privacy built into the solution, such as using of encryption while the data is being stored and while is it in motion. Identity and access management. This is one thing that we saw every member of a permission network is very concerned about. Like, they want to know what kind of sign-on and login capabilities are supported. Some of them want to integrate it with their own internal permissioning systems, while others want multi-factor authentication. And a key concern that came about is like, how do you manage your keys? Are you storing it in a standard database, or are you using some kind of a key management service? Now, for us, we learned that initial days, we want to have a simple solution because the cost of key management can escalate as the number of keys that we require goes up. To give a simple example, it costs about 70 cents per key if you use a solution like Key Protect. And if it runs into thousands to millions of keys, then the cost of blockchain solution per transaction can go up. So we have to engineer the solution to have the right key management services in place. Then we look at integration with enterprise applications. So data coming in from external sources we want to trust, and we want to make sure that oracles are in place that will certify that the data is coming from a trusted source and that it has not been tampered with as the data comes from these external parties into the blockchain. And last but not the least is that the blockchain solution behind the scene is not alone. What the end user sees is the user interface and how the user experiences. In our experience on many blockchain solutions, we have seen that user experience and how usability and user interfaces are designed plays a very critical role in the success of the solution itself. Now, these we feel are important criteria as we move a solution from POC, MVP, all the way into commercial production. Now, I do want to talk a little bit about Chainyard in the next slide. Chainyard is a blockchain company. It started off in the late 2015, early 2016. Initially, we partnered with IBM to test the fabric as it went open source. And since then, we have tested every release of fabric as it gets into the open source. We've also done our own solution, and we learned a number of things. How does one build a consortium? What does it take to build a consortium? What are the key considerations? And how do you establish governance as a part of the consortium? Our own internal innovation has focused on a number of blockchain critical technologies, such as zero knowledge proofs, tokenization, such as token taxonomy framework and the emerging Interwork Alliance work on tokenization and standardization. And lastly, the W3C community evolving standards around self-sovereign identity and verifiable credentials. So we've done a lot of work in this, and we've built internally, we've built capabilities such as frameworks, accelerators, and tools that help our clients to move very quickly from concept to POC and MVP. We've done a number of solutions in various domains, such as supply chain, manufacturing, transportation, logistics, to name a few. And we contribute to the Linux Foundation, the Hyperledger project, as well as very active participation in Blockchain and Transport Alliance. So we are very active, and we've built a boutique capability to help clients build blockchain solutions with real results. Now, Chainyard is a member of, is a part of a company that we call IT People. That's our parent organization. In the next slide, this is a representation of our parent company, IT People. So IT People was founded in 1999, and it's been headquartered in Research Triangle Park area of North Carolina. We've done a lot of work for many companies in different spaces apart from blockchain in the past. They include digital transformation, workforce solutions, and within that, we have done a number of applications, whether it is user experience or transforming legacy applications, modernizing and moving applications to the cloud. So that's IT People, which has been in existence for a long time. Now, as part of Chainyard, which is a blockchain consulting and advisory services a brand, we also have a solutions group within the Chainyard brand. And we built a solution called Trust Your Supplier, which is about digital supplier identity. It is in commercial production as we speak. And that has actually given us the expertise to help anyone take concept to production and what it takes, both from a business perspective, a technical perspective, operations, and service management. With that, I would conclude what I have to say and turn it back to Rod.
Okay. Thank you, Mohan. Again, I want to thank everybody, both Mohan and myself. Enjoyed working on this, and we appreciate your taking time to listen to us present the topic, and we wish you have a wonderful day. If you have any questions, our email addresses are on the intro page where you saw both of us. Please feel free to reach out to either one of us with questions, and we'll do our best to answer them and get back to you. Thank you.